All right, 9.2, the Pythagorean theorem. So the problems pretty much all are going to ask you, or we're like solving for them or something, are going to pretty much all ask you to find the unknown side length. So it could be the hypotenuse, could be one of the legs. And then it just says to simplify answers that are radicals. I don't really care about that. Like I said, I'm okay if you leave it as just the big radical. Now, if it's a perfect square, should I leave it as a radical? No, I should, find what the square root of it is. But you can also do it as decimal, so your answers might look a little bit different than the book, and that's okay. 8. Have the triangle here, and you should have no problem drawing the triangles with this section. 6, 9, and x. All right, so our Pythagorean theorem, I'm not going to necessarily write it every single time, but a squared plus b squared equals c squared. So then I'm going to replace, does it matter which thing is a and which thing is b? Nope. So it doesn't matter. You can plug it in wherever you want. So I'm going to just do x squared plus 6 squared is equal to hypotenuse squared, so 9 squared. So x squared is just going to stay. 6 squared is. And 9 squared. And so then we would subtract. So x squared is equal to 45. And then we take the square root. So x is equal to the square root of 45. Is that a perfect square?
No.
Nope. So we can leave it here. Or we can actually take the square root of that number.
6.7.
It's what?
6.7.
Is it actually, or are you joking?
Yeah, so it's actually,
Just making sure. So either of those ways to write it are fine. Anyways, like I said, this stuff should be pretty easy. 10. I guess I should have asked on this one. Was this a Pythagorean triple?
no.
No. If it's not a perfect square, it's not a Pythagorean triple.
Oh, that's easy to remember. That's way simpler.
All right, so we're going to set this one up. Again, I'm not going to write the formula every time because you have it in your theorem and postulate book. If you don't already have this formula memorized, then you probably should write it every time until you memorize it. But so we have our hypotenuse is what I'm solving for this time. So I've got 9 squared plus 40 squared is equal to x squared. 9 squared is 40 squared is
1,600.
1,600.
Oh, yeah, you just have to answer it.
And then on this one, it's nice and easy. We just have to add them together. So 1681 is equal to x squared. Take the square root.
41.
So I would recommend, even if you're going to leave your answers in a radical, like if you decide that that's the option you're going to choose, you should still plug them in a calculator, because if it's a number that is a perfect square and you don't write the perfect square, I mean, I know this isn't just like a known perfect square, right? But I'm going to take points off if you don't write down the perfect squares the way that they are. So at least type them in, even if you're going to leave your answer this way, because obviously if it comes out to be a perfect square, then you need to have that. Now, also, if you don't check it and see that this is a perfect square, you're not going to know that this is a Pythagorean triple. So this one is 1. And you can just write yes, because it's technically just a yes or no question in the instructions. It just says tell if it's a Pythagorean triple. So just a simple yes or no we'll do on that. 12. All right, this one looks a little different. So I'm still solving for the variable, right, which is the unknown side length. But I don't technically have two sides of my triangle that I know, or do I?
Yeah, you
You do.
I do. Why?
Because they're
They're
congruent.
congruent.
Yep, these are marked congruent, so don't forget that from, previous chapters. So that means that this side over here is also 3. And don't let this extra part over here confuse you. Once you mark down that that side is 3, you can basically just cover that up because it is irrelevant at this point. So we've got 2 squared plus 3 squared is equal to x squared. 2 squared is,
4.
3 squared is, so I've got 4 plus 9 is equal to x squared. 13 is equal to x squared. Take the square root. Square root of 13 is equal to x. Is that a perfect square? Nope. So we can either leave it here or somebody tell me what the decimal is.
3.6.
So we can also write it that way, and that would be totally fine. Is this a Pythagorean triple?
No.
I guess the one that we talked about that I didn't write, but I should go back up here and write now. 14. All right, so this is all the information that they give me on this problem. So what am I going to need to do?
You're gonna need to find the hypotenuse of the triangle on the top because you can find that. What? No, you can't. I'm already.
Whoa.
Oh, wait. I forgot to write a number. Hold, please. There we go. Sorry.
Okay, now we just do
It was blending in the problem.
Oh.
So I was like, they're making this really tricky. Do we need to go back and use the diagonal formula? Then I was like, oh wait.
It would be
I
equal
know,
to
I figured
20.
it out.
Do what?
That side would be equal to 20.
Yep, this side over here is going to also be 20 because they're congruent. Or we could say this side is x, depending on if you want to solve the top or the bottom triangle. They're congruent, so it doesn't matter. But, so somebody tell me I set this one up this time.
29 squared equals 20 squared plus x squared.
29 squared is equal to 20 squared plus x squared. 29 squared is
800.
841.
Yeah. Equal to 400. Then squared. Minus 400 to the 841.
So what does that give me?
Hmm?
So what does that give me?
141.
441 is equal to x squared.
Then
X is equal to 21 because you square root of 441 and that comes out of 21.
Is this a Pythagorean triple?
Yes.
16. Find the value of x, simplify answers that are radical. So these ones are just a little bit more involved. Wait. All right, so what do I know about this triangle?
You know the legs.
What are they?
8 and x.
Base. That's the base.
Okay, I know what you're saying. What do I know about the big triangle?
It has a base of 16.
Okay. What else?
It's equal to
Height is x.
I was gonna say.
Say it again.
Angular.
What does that mean?
All the angles.
Okay, what does that mean about the sides?
All sides are congruent. Sorry.
All the sides are congruent, so that means that these sides also have to be 16. Because otherwise I don't have enough information to solve for x. Now I can go to the smaller triangle, right? And I can solve for x. So how do I set this one up?
8 squared plus
X squared.
equals 16 squared.
Yep. 8 squared,
64.
64 plus x squared is equal to 16 squared.
256.
Subtract 64.
192. X equals the square root of 192. And that does not go down as the root.
So you can leave it here. Just out of curiosity, what's the decimal?
13.5. 13.85.
So 13.9. All right, so either way, again, would be fine.
No. So when we're using the Pythagorean theorem, A is always going to be the bottom, like the base length, and then B is the like up and down.
Well, those don't matter because it just depends on which way your triangle's oriented. That's why I said earlier they can be whatever way.
So they're like interchangeable.
A and B are, yeah, they're whatever. C is the only one that has to be the hypotenuse. The other two don't.
And the hypotenuse is always
The longest side.
Okay.
Yeah, whatever you're solving for, like the side length should make sense. So like if I'm solving for the hypotenuse and I get a really tiny side length that's smaller than the other side lengths, then I know something's wrong, right? Because our hypotenuse should always be the longest side of our triangle. 18.
Right.
You can find the base of the really tiny triangle, of the smaller triangle.
Okay. How?
5 squared minus 3 squared is equal to the base of the thing. So
Okay, so let's do this. We know that we're ultimately solving for x, but we only know that I'm going to say the base of this entire triangle. Realistically, this is actually, oh no, it's not, never mind. The base of this entire triangle we know is 11, right? So I need to solve for this base of this little part right here. Okay, so this would be 5 squared is equal to 3 squared plus y squared. 5 squared, 3 squared, and so then plus y squared, subtract 9. 16 is equal to y squared, so y is equal to 4. So that means now that this side length here is 4. Would this be a Pythagorean triple if I only had this little triangle?
Yes.
Yes.
Yes, because they're all integers. All right. Now, what does that mean that this side length is over here if this is 4?
7.
Yep. This would be 7. So that side length, sorry, that's kind of hard to see. So that side length is 7. So now I can actually solve for x. How would I set this one up?
7 squared plus 3 squared is equal to x squared.
7 squared plus 3 squared equals x squared. 7 squared is 3 squared is equal to x squared. 49 and 9. 58 equals x squared. Then what?
Square root of 58 is equal to x.
Is that a perfect square?
No.
What's as a decimal?
7.6.
So again, either way would be fine. And remember, I wouldn't recommend you put x over here because this is going to confuse you. That's why I chose y to be my variable when I was solving this first one. So just make sure you watch for that stuff. Find the area. So I'm going to make a note here that this is area now instead. So for the area problems, you're going to see that the triangles are filled in on the quiz and the test. They may or may not be, so you just need to make sure you read the instructions. And then also pay attention to units with these. So area formula is 1/2 base times height. Do I have both of those pieces of information? I do not. So what do I need to do? How?
Pythagorean theorem.
Pythagorean.
Minus
Pythagorean. Pi. Thag. Orion. All right.
Who cares how I pronounce it though?
I do. I'll take points off if you don't pronounce it right. How do I find this?
14 squared minus 5 squared is equal to x squared.
Let's not confuse people. 14 squared is equal to a squared plus 5 squared. If you can go straight to what you said, that is totally fine. But I think a lot of people are going to get confused. 14 squared
196.
is equal to a squared plus 5 squared.
25.
Subtract 25.
171.
So we got then the square root of 171. Is that a perfect square?
13.07.
So I would probably leave, well, it's fine. You can go ahead and find the decimal. So then I'm going to plug it into the area formula. Area is equal to 1/2 times the square root of 171. Or if you've already found the decimal, that's fine. Times the height is 5. And what is that?
Area equals 32.75 meters squared.
32.7 meters squared.
Area always ends up being meters squared, right? Or just the units.
Units squared, whatever the units are, because some of them are not meters.
Yeah.
It looks like all the even ones are meters, but in technicality, they're not necessarily. 28. Do I have enough information to find area? What do I need to do? How?
5 squared.
This isn't a right angle, so this isn't a right triangle on the outside. So what does that mean I'm going to have to do?
5 squared plus 4 plus x squared, or
The one on the bottom.
This is the hypotenuse. That means it's got to be written by itself. 5 squared
The one on the bottom.
is equal to 4 squared plus, I'm going to call this x, x squared. 5 squared. Who's got AirPods? Whose AirPods are going off?
Probably mine.
Okay. 4 squared.
16.
25 minus 16. Oops, forgot the square. Square root. Alright, so this little part is 3. Hopefully by the end of this lesson, you will just have recognized that and not have needed to do the work. It's 3, 4, 5 triangle. Alright, now I need to find this base over here, because I need the base of the whole thing in order to find the area. So what is, or how would I set this one up on this side?
8.5 squared equals 4 squared plus y squared.
8.5 squared. Probably gonna have to throw that in the calculator.
$72.25.
72.25 is equal to 4 squared
16.
plus y squared. Subtract 16 from the 72.25.
Like subtract it? 56.25.
What was it?
56.25.
Shouldn't be 2.5.
66.
Doesn't make sense. We have a calculator. Can we not type this in?
56.25.
Oh my, it's 56.25. That calculator gave us.
Okay. Square root.
Square root is 7.5.
Is that rounded?
No, it's just 7.5.
Okay. All right, so now what is the base of the entire thing?
10.5.
So 10.5 is the base of the whole thing. So now I need to do area. 1/2 base, so it's 10.5 times height is 4.
Area equals 21 meters squared.
21 meters squared. Questions on any of this? Okay. Problems. 7 through 17 odd, and then 25 and 27.